All right, guys, take a look at this triangle. This triangle has a measure of 30 degrees, an angle measure of 70 degrees, and an angle measure of 80 degrees. So if I take this and I copy and paste it, okay, and I shrink this new one down, are these two triangles congruent to each other? The answer is no, they're not, because remember, congruent triangles have congruent corresponding angles, right? So we have that 30 degrees is congruent to 30 degrees, 70 degrees is congruent to 70 degrees, 80 degrees is congruent to 80 degrees. So our corresponding angles are congruent, but visibly you can see that this triangle on the right is much smaller than the triangle on the left. So while these triangles have a lot in common, they're not identical to each other, right? You can clearly tell there is a difference between these two. You wouldn't get confused between the two triangles if you put them side by side, especially. So let's give some side lengths to this. Let's say we have a side length of, let's say we have a side length of 10 here and a side length of 12 here. And let's say over here we have a side length of 5 and a side length of 6. Okay. And I'm going to go and give a third side length as well. Let's say we have a side length of, let's go with 6 there for our side length. Okay. So 10 corresponds to 5, right? Because 10 is between the 80-degree angle and the 30-degree angle. 5 is between the 80-degree angle and the 30-degree angle. 12 corresponds to 6 because 12 is between the 30-degree angle and the 70-degree angle, and 6 here is between the 30-degree angle and the 70-degree angle. And then this side here that has a measurement of 6, it's between the 80-degree angle and the 70-degree angle, and we don't have a measure for that. What do you think this missing side length is going to be? See if you can find the connection. Well, 10 down to 5, we divided by 2. 12 down to 6, we divided by 2. So 6 divided by 2, and we get 3. And that's true, that these two figures are similar. That is a mathematical term, similar. And what does similar mean? It means the same shape, and not necessarily, uh, if I can spell necessarily, Necess, I think that's it. Not necessarily the same size, okay? Now, if they are the same shape and they are the same size, they are congruent. So congruent figures are similar. Not all similar figures are congruent. So these two are similar but not congruent. So we would just say these are similar, okay? So these are similar figures here. And in similar figures, there's a couple things that are happening. One is the corresponding angles are congruent. That has to be happening. Corresponding angles are congruent. And you can see that here, 30 and 30, 70 and 70, 80 and 80. And the corresponding sides are proportional. Okay? Corresponding sides are proportional. Now we can set up proportions for this. We've done this before in math class. So 12 here corresponds to 6. And that is going to be equal to 10, which corresponds to 5. That's going to be equal to 6, which corresponds to 3. What's 12 divided by 6 is 2. What's 10 divided by 5? It's 2. What's 6 divided by 3? It is 2. So this leads us to what's called our similarity ratio. Our similarity ratio. And the way we find our similarity ratio is we divide corresponding sides. So 12 corresponds to 6. 12 corresponds to 6. 12 divided by 6 is 2. So the similarity ratio here is 2. Now, if you went the other way, if you flipped all these around, and I'll do that so you can see it, you could say 6 over here corresponds to 12 over here, and 5 over here corresponds to 10 over here. So 5 corresponds to 10. So we're going small over big. Earlier we went big over small. Now we're going small over big. And 3 corresponds to 6. Well, if we simplify all these, you would get 1/2. How is 2 related to 1/2? Well, think about 2 as a fraction. 2 as a fraction is 2 over 1, right? So if you flip it, you get 1 over 2. It's always going to be that way. So I would take, if you told me the similarity ratio was 2, I would take it. If you told me the similarity ratio was 1/2, I would take it. Either one is okay because it depends on whether you're comparing big to small or small to big. All right, so now let's take the IXL and see what's going on over there. Okay, so here's the first one I have. And these two figures, or if these two figures are similar, what is the measure of the missing angle? Ideally, we have more information than this, but you can tell what corresponds to what. So this angle down here is going to correspond to this angle down here in the bottom right. This obtuse angle up here in the top right is going to correspond to this obtuse angle up here in the top right. So 90 degrees and that missing angle, they correspond to each other. Remember, as we just said a moment ago, where was it? Right here. In similar figures, corresponding angles are congruent. 30, 30, 70, 70, 80, 80, corresponding angles are congruent. So 90 corresponds to that missing angle. So they're both 90. Let's try another one. In these two figures, or if these two figures are similar, what is the measure of the missing angle? Again, you can tell it's the same shape, just shrunk down a bit. So 113 corresponds to that missing angle. So 113 degrees. In similar figures, corresponding angles are congruent. If these two shapes are similar, what is the measure of the missing length S? Okay, now this is where it gets a little tricky, and this is where you probably need to pay attention and maybe even rewatch this part of the video. So I'm going to copy and paste this over here into whiteboard so we can take a look at it. All right, so we got these two triangles and we know they are similar to each other. And we're just kind of, ideally we would have a similarity statement and we would have the corresponding sides identified through that, but this is going to work as is. So 6 is the longer side, visibly is the longer side, and 3 is visibly the longer side. So 6 corresponds to 3, and that's going to equal, so I did the bigger triangle, S, over the smaller triangle, 1. Okay, and maybe you can see what's happening. So 6 divided by 2 is 3, so something divided by 2 is 1. You might be able to tell right away what S is, but if you can't tell, let me show you how to do it. We're going to cross multiply. You remember doing that? 3 times S is 3 times S. 6 times 1 is 6. We then divide both sides by 3. 6 divided by 3 is 2. So S is equal to 2. And we can double check that, right? So 2 divided by 2 is 1. 6 divided by 2 is 3. And it goes the other way as well. 3 times 2 is 6. 1 times 2 is 2. So that works out. So S is equal to 2 there. And maybe you can do that without even doing the math. That's okay, but it's not always going to be this simple. All right, if these two shapes are similar, what is the measure of the length of D? Okay, well, 8 down to 4, we divide it by 2. Something divided by 2 gives us 1. Oh, let's go the other way. 4 times 2 is 8. 1 times 2 is 2. Again, 4 times 2 is 8. 1 multiplied by 2 is 2. Corresponding sides in similar figures are proportional. So our similarity ratio there would be 2. If these two figures are similar, what is the measure of the missing angle? Well, I noticed that this is an obtuse angle. So just visibly it's an obtuse angle. So the obtuse angles here are 139 and 139. So 139 is my missing angle there. If these two shapes are similar, what is the measure of the missing length K? Okay, well, the shorter side appears to be 3. So 1 multiplied by 3 is 3. 3 multiplied by 3 is 9. Let me show you what's going on mathematically with this. In case you're wondering, we're going to set up a proportion and solve this one. You might not need to do it. That's okay. But again, there's going to be some numbers that are a bit more difficult to work with than this. And so if you can understand it with the simple numbers, when the more complex numbers show up, you hopefully won't be at a loss. Okay, so let's set up a proportion here. Let's say 3 and 1, right? So 3 corresponds to 1. That was that 3 corresponds to that 1. We did big over small. I didn't have to, but I did. So we'll do K, big, over small 3. Again, 3 here corresponds to 1 here, and K corresponds to 3, so K over 3. We then cross multiply. 1 times K is K. 3 multiplied by 3 is 9, so K has to equal 9. And let's double check it. 1 multiplied by 3 is 3. 3 multiplied by 3 is 9, so K is 9. If these two shapes are similar, what is the measure of the missing length Q? All right, well, 4 multiplied by 3 is 12. 1 multiplied by 3 is 3. Let's double check. 4 times 3 is 12. 1 times 3 is 3. If these two figures are similar, what is the measure of the missing angle? Again, they're clearly the same shape, just one is shrunk down. So 70 degrees here, 70 degrees here. You need some sort of proof that it's similar. If you're being told that they are similar, that's good enough. But just because they appear to be similar, you cannot assume that they are. Like maybe this would have been a 71-degree angle and this would have been a 70-degree angle, right? So maybe they're very close to one another, but not exactly the same angle measure. But in this case, we were told they were similar, so we can assume they are. If these two figures are similar, what is the measure of the missing angle? Again, we're told they're similar. This is appears to be a right angle in the bottom left. We have our acute angle in the bottom right. We have our obtuse angle in the top right, and then two right angles, so 90 degrees there. If these two figures are similar, what is the measure of the missing angle? The acute angles are 58 in this other figure. This is an obtuse angle. Both the obtuse angles are 122. If these two shapes are similar, what is the measure of the missing length h? Okay, well, let's see. 4 appears to be the shorter side. It corresponds to 1. H is the longer side. It corresponds to 2. So 1 multiplied by 4 is 4. 2 multiplied by 4 is 8. Let's double check that. Let's go the other way. 4 divided by 4 is 1. 8 divided by 4 is 2. You could have cross multiplied and solved too, but this was simple enough where I could do it mentally. If these two shapes are similar, what is the measure of the missing length W? All right, this is one where I am going to cross multiply here. You'll probably want to use your calculator on something like this just to be sure you don't make a calculation error. Okay, so let's take a look and try to figure out what corresponds to what. We have a longer side of 36, a shorter side of 24. So let's take a look at the longer side, 36. This longer side of 36, what do you think it corresponds to, 48 or W? Just visually, it appears that this triangle on the right has been blown up a bit, and it looks like it corresponds to 48. So we're going to say 36 over 48. So we did green over pink. So we're going to stay with that theme, 24 over W. And now we cross multiply and solve. 36 times W is 36W. Again, go to your calculator. Your calculator is your friend here. 48 multiplied by 24, and I get 1,152. It's a big number. Calculator makes it pretty easy though. 36 times W, we need to divide by 36 on both sides. 1152 divided by 36, and we get W equals 32. Okay. So W equals 32. By the way, if you wanted to know what the similarity ratio was, you could take 36 over 48, simplify it, 36 divided by 48, which that simplifies to 3/4. or 0.75. So 48 multiplied by 0.75 is 36, and 32 here, right? 32 multiplied by 0.75 is 24. But anyway, W is 32. W is 32. 32. Okay. If these two shapes are similar, what's the measure of the missing length S? All right. Oh man, this is gonna be tough because it's tough to tell what's longer on these two. Let me pause the video and get this set up here. All right, I'm gonna work this both ways and see if one way gives me an integer and the other way does not give me an integer. So let's say 80. Let's see, let's say 80 corresponds to 32. So I did pink over green. That means S has to correspond to 36. This might be it. This might not be it. It's kind of a funky question because it's tough to tell which one's longer. So 32S is equal to 80 times 36. 80 times 36. So if this were a test question, I would probably tell you, you need to be told what corresponds to what. Now, sometimes you can obviously tell visibly, but this is one where you would have to be told. So if you came up to me during a test or a quiz, I probably should have told you in the test or the quiz, but if I didn't, I would definitely tell you in that time. So we divide both sides by 32 and we get S equals 90. Now let's try it the other way. Let's say now 80, instead of corresponding to 32, let's say it corresponds to 36. Okay, and then that means S has to, instead of corresponding to 36, it corresponds to 32. Same idea, we cross multiply and solve. 36 times S is 36S. 80 times 32 equals 2,560. We divide both sides by 36. And yep, so we get S equals 71.1 repeating. So while you can't tell visibly very easily what corresponds to what, the fact that we're getting this as one of our answers, 71.1 repeating, we're going to say that one is not the true answer. We're going to go with the one that's the integer. So we're going to say S equals 90 on this one. So just keep that in mind. If you have a problem like this where it's hard to tell what corresponds to what, check them both out. And then if one of them's an integer and the other one's not, go with the integer. If we would have gotten two integers here, I would have had to just close my eyes and guess, and hopefully I got it right. And if not, then curses to IXL. Let's see. Got it. Okay. Let's keep going. This is an obtuse angle. Obtuse angle is 115. That one was much easier compared to the previous one. Okay, if these two shapes are similar. Okay, so obviously 1 corresponds to 3, so 1 times 3 is 3. 2 times 3 is 6. Again, 1 times 3 is 3. 2 times 3 is 6. The similarity ratio here is 3. All right, if these two shapes are similar, what's the measure of the missing length C? This will be the last one I work, I think, on this video. Okay, let's see, Control C. I'll just pause this. All right, so on this one, very clearly we have a longer side. So I'm going to say long side 56 over long side 98. So I did green over blue, which means I have to stay with green over blue. So that's short side C over short side 28. We cross multiply and solve. 98C equals 56 times 28. With the calculator, 56 times 28 is 1,568. We then divide both sides by 98. Back to the calculator, 1,568 divided by 98, and we get C equals 16. C equals 16. Back to IXL, there you go, 16 meters. All right, guys. Thank you very much for watching. Good luck on your assignment.